Let's take a few minutes to discuss some test environment considerations for where you tune and test your SQL statements, and for where you will perform any application level performance testing. Not having an appropriate test environment set up to do your performance tuning and testing is one of the most common mistakes that is made when trying to performance tune an application. So let's see what the important considerations are so you can make sure that the performance tuning that you do on your application is as effective as possible. One of the primary considerations that you want to keep in mind is the size of the database that you're using to test your applications and perform any performance tuning activities. Too often times, what happens is that both in our development and test regions, the database used in these regions contain only a fraction of the amount of data that is contained in production. While this may be sufficient for application development and functional testing, it doesn't work for any sort of performance testing or tuning. And so the result is that your application runs very fast in your development test regions, only to encounter performance issues when it's deployed to production. There are a couple of reasons behind this. First of all, hardware has gotten fast enough these days that for a small database, almost every statement runs relatively fast. If most of your tables contain just a few thousand rows, it may be that Oracle is able to keep the entire database in memory, so you never incur any disk access, which of course is highly unlikely once you move to production. Also, modern processors have gotten fast enough that even if Oracle has to sequentially scan through a few thousand rows in a table, this is no big deal. But when the same SQL statement runs in production, now you're scanning through hundreds of thousands or even millions of rows, and this is a problem. There is a second reason at work though, and this is the fact that Oracle may have actually used a different algorithm to execute the SQL statement between the two regions. When I say that Oracle used a different algorithm, don't worry, this isn't a malfunction in Oracle or any sort of defect. It is actually design behavior, where Oracle is evaluating the most efficient way to process your SQL statement, but this can and will vary depending on the data in your database. So let's understand why this is. As application developers, we are most familiar with a programming paradigm known as imperative programming. This is the paradigm that we use in languages like C, C++, C#, and Java. In imperative programming, we're not just defining what we want our program to do, we're defining how our program will perform that action. For example, think of a sorting algorithm. We aren't just saying sort this array of data. We are also providing the implementation of the algorithm to use, whether a shell sort, a bubble sort, quick sort, or some other algorithm. The important point, though, is that we're not just specifying the result that we're going to get back, but also each step in the algorithm to be performed. So regardless of the input data that's provided, the algorithm remains the same. When you write SQL, you are using a programming paradigm called declarative programming. In declarative programming, you are only specifying the result that you want, and it is up to some other entity to determine how specifically to achieve those results. In Oracle, what this means is that your SQL statement, let's say a query, is saying, I want to get back these columns from these tables, and here in my where clause, this is the matching condition to use to determine what rows I should get back. What happens then is that the Oracle Optimizer examines your query and determines the most efficient way to perform that query. This could be by scanning the table directly for matching rows, or could be by first using an index to find the rows and then reading the table. If you have a join in your query, the Oracle Optimizer will choose amongst several options for the best way to join the data together. The important point, though, is that it's the Oracle Optimizer that is making the decisions about the specific steps in the algorithm to use to perform your query, and to do so in the most efficient manner. And what steps are used may differ depending upon the data that is involved. What this means is that in order to conduct effective performance tuning and testing, we need to create a test environment that effectively replicates our production environment. This environment needs to contain a similar volume of data as our production environment, as well as a similar distribution of data, because the distribution of data can also affect how Oracle will execute your SQL statement. Otherwise, if we run a SQL statement in two different environments that have differing data, either by the amount of data or the distribution of data, we are probably going to get different answers from each environment. Both answers will be correct with respect to the environment that they were run in, but the results won't translate from one environment to the other. By having a test environment that mirrors production, we can be confident that any tuning or testing we do in this environment will be representative of the results that we would get in production. So when we analyze a SQL statement our application is running, or we evaluate an indexing strategy that we are considering, we know that the results we're getting in our test environment will translate to our production environment. And this is the whole point. We want to have a test environment where we can get a good read on the performance of our application, and then work to improve our performance by trying out different solutions. So it is absolutely critical to have a test environment where we can perform these type of activities.